Assalamu alaikum students. Today we have to read about conservation of mechanical energy of a freely falling body. By mechanical energy you are able to understand that I am talking about the potential energy and the kinetic energy of the body. And freely falling body means when a body falls only under the effect of gravity, and we have to neglect the air resistance also. Only under the effect of gravity. No another force acting on it. So for that very purpose, we consider a body at point A which is at a height of h from the ground. Once it is at a height of h from the ground, then at this very point, it is having what? The two types of energy. So the potential energy at point A, potential energy at A, that simply equals to m, that equals to g, and that equals to h. That's mgh. But at the same time, the kinetic energy at A, that's equal to simply 1 by 2 m into v square. That simply equals to, at this very point A, as the body is at rest, so there is no velocity, hence the kinetic energy becomes as 0. So total energy at A equals to what? M g h plus 0, that is simply mgh. This is the total energy at what? A. Now, if at the point B and if at the point C we are having again the same energy, then we will see that there is conservation of energy. At point A, the total energy of body, the sum of the potential energy and the kinetic energy. As the kinetic energy vanishes because body is at rest, then the body is having only one energy, that is the potential energy, because of the height factor, and that is simply mgh. Then total energy is the sum of the two, and total energy comes out to be mgh. Now let the body is allowed to fall freely. As it falls freely, it is going to move, and we will find out that its potential energy decreases. Why its potential energy decreases? Because its height with respect to ground decreases. So as the body falls freely, its potential energy decreases, but its kinetic energy increases because its velocity goes on increasing. Let at some time t, its position be at point B, and it has covered a distance of x from the initial point. From this very point A to this very point B, we are having a distance of x, and from point C, that is from the ground up to point B, we are having a distance of h minus x. So simply, I will say at point B, the velocity attained by body. So now at point B, at point B, once again, as the body falls freely, at as it falls freely, it reaches to point B, we will say. So it will be having a lesser amount of potential energy, but it will be having a greater amount of kinetic energy as compared to here, which was 0. At point B, as the body approaches, let its velocity be v dash. So in order to find out this v dash, we will use the third. We can calculate this v dash by using the formula v square minus u square is equal to 2as. So v square, that is the final velocity, we are going to use v dash square minus u, that is the initial velocity, that is simply 0, that is 0 square equals to, now instead of a we have to use g, and instead of s, what distance is that covered? It has covered a distance of x, we will use x here. So it is having velocity of this very much. Now what will be its kinetic energy? Therefore kinetic energy equals to 1 by 2 m into v dash square equals to 1 by 2 from this equation, which implies we'll get v dash square is equal to 2gx 1 by 2 m into v dash, that is simply 2gx. This 2 and 2 will leave, it is simply mgx. Now this is the kinetic energy. Now what will the potential energy be? Potential energy at B equals to what? It will be m, it will be g, and it will be the height of point B, the height of point B where the body lies from the ground, that is h minus x. H minus x. Just combining this and this, therefore total energy at B equals to mgx, which I will take here, that is the kinetic energy, plus potential energy, that is mgh minus x. Now solving it, it will be mgx plus of mgh minus mgx. This and this will leave, again it comes out to be mgh. Now this is second, this is first. Now we will take its total energy at point C. Now at C, let the body is having, as it approaches close to the ground at point C, now it will be having a totally, it is at a height of 0. So at C, potential energy equals to mg into 0, that is simply 0. There is no potential energy. But let the body is having some velocity v double dash. Let v double dash be velocity at C. Once v double dash is the velocity at C before touching the ground, so just calculating it by calculating v dash, that is calculate v dash by using the equation. Now using equation, v square minus u square is equal to what? 2as. Now instead of v square, we will be having v double dash ka square minus u square, that is initial velocity, that is 0, is equal to 2, it will be g, and now s is equal to the h, because the body has now come down from A to C, it will be simply h. So which implies v double dash square is equal to what? 2gh. So kinetic energy is equal to 1 by 2 m into v double dash square is equal to 1 by 2 m into 2gh. This and this leaves, it comes out to be mgh. Therefore total energy at C equals to mgh. From this equation as well as this, from first, second and third, we can calculate that the energy is conserved, that the sum, the total energy during the free fall of a body under the action of gravity remains constant. That is how we are going to show that whatever is the energy, if once again we will look, whatever is the energy at point A, same will be at B and same will be at point C. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.